In this video, we're going to cover the basics of R programming. By the end of this video, you should understand what a comment is in R and when it's appropriate to use comments, what an expression is in R. You should be able to identify the common mathematical operators in R. You should know R's order of mathematical operations. You should understand what a variable is, what you use them for, and how you use them. So how do we go about programming in R? If you recall from previous videos, R can be used as a procedural programming language, and for most of this class, we're going to treat it as a procedural programming language. So how this works is, we provide R with a series of instructions. Each instruction is called a statement. R is going to read a statement, execute it, and then move on or wait for the next statement. Often, we want to execute more than one statement in R. R scripts consist of a series of statements in a script file. This is generally how you'll string statements together. These are text files that end with the .r extension. When you run a script, R is going to attempt to execute every statement in that file in order from beginning to end, starting with the first, and then moving on through each instruction until the end. I'm going to start off by talking about the most important instruction you'll ever learn in R, but it's a command or a statement that does nothing, and these are called comments. So unlike most of the other content of your script files, comments are intended for humans, not for R. A comment is text that you're going to include in your R script file, perhaps to give someone context when they're looking at your code, maybe to explain complicated operations. You could list assumptions that you made, or anything else that someone, including you in the future, might find helpful for understanding your code. I can't emphasize this enough. You might write some code, put it aside for a few months or even a few years, and then come back and look at it and wonder who exactly wrote it. Comments can help you not only inform other people who read your code, but yourself in the future. Comments in R start with the number sign. You can call it a hashtag if you want. I've heard it called an octothorpe, many names for that symbol. The way a comment works is if R encounters one of these symbols, it's going to ignore any text on the remainder of the line. This means you can write anything that you want after the number sign. So when should you use comments in R? I advocate that you should comment your code liberally. The costs of writing comments are very low. You're putting thoughts that are in your mind when you're writing your code into text form in a script file as you're writing it, and the benefits are incredibly high. It's really easy for people to ignore comments if they don't need to pay attention to them, so adding additional comments to your file that people don't find useful don't really have that much of a cost for people reading the file. But it's hard to put yourself in the mind of someone who wrote the code, even when that person was you just a week or two or maybe even a month ago. So being clear about your thinking improves the transparency of your code and can help someone trying to reproduce it as well. In this class, I'm going to require you to provide copious, clear, and insightful comments in your R code. Building these habits now really help in the future, but don't take my word for it. A while ago, I got an email from a former AREC 380 student who told me, "Recently, I've been using R in my internship, and I've been deciding to replicate models. It made me realize how important comments are in R. I spent a whole week going through someone else's code and making comments so I could actually understand what the heck they did. I really wish they had a professor as enthusiastic about comments as you are." So again, don't just take my word for it. Comments are an excellent way to document your code and to make it more transparent. So now that we've covered the most critical component of the R language, comments, let's move on to talking about the second most critical component, the basic building block of all programs in R, which are expressions. An expression in R is a combination of variables, or values, functions, and operators, all using the R syntax. These are often going to resemble mathematical expressions. For example, 2 plus 2 is a valid R expression. What do you think this instructs R to do? Well, let's take a look. Entering 2 plus 2 into R tells R to take the number 2 and add it to the number 2, and then return the result. So here I have 2 plus 2 in the code editor. If I run that little bit of code, you can see in the output window, it shows me that 2 plus 2 is equal to 4. Obviously, you're going to want to construct more complicated expressions in R than just 2 plus 2. So how does this work? R is going to read one full expression at a time and attempt to process it. Expressions end at the end of a line. Expressions can be more than one line. The requirements for this are that quotes, parentheses, and brackets match. So for every left parenthesis you have, you're going to need a right parenthesis, even if it crosses lines. And if you want something to span more than one line, you need to have an operator at the end of a line. I'll show you exactly what all of the operators are in a couple of slides. When an expression covers multiple lines, it's generally customary to indent the subsequent lines to show that you're spanning several lines with an expression. The nice thing is, RStudio does this for you automatically. So I've written out two expressions here. The first one is a valid expression. Each line ends with an operator. That's telling R that it needs to continue afterwards when it's reading through everything. The second expression starts with 2 plus 5 and then ends there. Then the next line starts with an asterisk, which is the multiplication sign. What R is going to do is it's going to think the expression is over at 2 plus 5, execute that, compute the value, then look at the next line and realize that there's something wrong because you can't start multiplication without something on the left-hand side. Let's take a look at how this would actually work in R. So you can see that first expression from the slides at the top of the code editor window. You'll notice that if I highlight that piece of code and tell R to run it, I get the result of -8. Now the next version of that expression, you'll notice first of all that RStudio is showing that there's an error here by using a red X on a line number. If you hover over that, it actually tells you what the error is. In this case, it says there's an unexpected token, which is the multiplication sign. And that's telling you that multiplication requires something on both the left-hand and the right-hand side. Now, if I try to run this section of code, what you can see is, first, R did attempt to add 2 and 5, and it got a result of 7, and then it moved on to the next line. Notice the line started with an asterisk and decided to stop there because it doesn't know how to multiply when there's nothing on the left-hand side. Expressions combine information and operators. So what exactly are the operators in R? So an operator is going to instruct R to perform some kind of operation on data. The common operators are just mathematical operators. So for example, the plus sign says that you should take whatever's on the left-hand side and add it to whatever's on the right-hand side. The minus sign will subtract whatever's on the right from whatever's on the left. The multiply sign will multiply the left and the right side together. And the divide side will divide the left side by the right side. More complicated expressions are possible by using parentheses. So for example, you can put a plus b in parentheses. R will add those two numbers together, then multiply by c. Just like in middle school math, R has an order of operations. The way things work is it's first going to look inside of parentheses and evaluate everything in there. Then it's going to evaluate functions. We'll talk more about functions in the next video. So the square root function is sqrt with some parentheses. After it evaluates stuff inside parentheses, it would evaluate something like square root. Exponent is the caret, which is shift and 6 on your keyboard. Then it will move on to logical operators. We'll talk about those later in the class. Then it evaluates multiplication and division, followed by addition and subtraction, and lastly, assignment. And we'll talk about assignment operators at the end of this video. So let's use R to settle the great internet debate of 2018. If you paid any attention to Instagram, there were a bunch of celebrities arguing over the solution to this math problem. 8 divided by 2 with 2 plus 2 in parentheses afterwards. What does R have to say about this? Well, this is invalid syntax. Even if you could type a division sign on the keyboard, R doesn't know what to do with the 2 hanging around outside the parentheses there. You have to give it some operation to tell it what to do with the 2 and the parentheses. So let's fix that a little bit. We'll change the division sign to the slash, which is the sign that you use for division in R, and we'll put a multiplication sign between the 2 and the parentheses. So what does R have to say about this? This is exactly the same as 8 times 2 to the negative 1 times 2 plus 2 in parentheses, which is the same as 8 times 1/2 times 2 plus 2 in parentheses. So what do we get from that? Taking a look at R, we have 8 divided by 2 times 2 plus 2 in parentheses. I'll run that little bit of code, and the result that you see that I get here in the console is 16. So the answer that R gives me here is 16. But what's the point of this discussion? Is it just because I want to show the Twitterverse who's boss? I really want to drive home the point that R's order of operations make every expression unambiguous. The reason this was such a big internet sensation is people didn't know how to evaluate. There was ambiguity in how you should evaluate the division sign and the parentheses. That led people to different answers. However, when you type expressions in R, there's no debate about what answer R should get. There's only one order in which the expression can be evaluated, and everyone entering the same expression into R will get the exact same answer. This is very important for reproducibility. Another important component of R expressions are variables. What's a variable? Well, a variable in R stores a result from a previous expression. Variables can be almost anything in R. They can be a number, a data table, a graph, an audio clip, etc. The way that you use variables is that you can assign a value to variables in one of 3 ways. The first is a right arrow that is constructed by a hyphen followed by a greater than sign. The second is a left arrow constructed by a less than sign followed by a hyphen. And the last is just the equal sign. Each of these are called assignment operators. And the way that they're going to work is the arrows point towards the variable. So when you use a right arrow, you're going to put an expression on the left-hand side, and the result of that expression will be stored in the variable that's on the right-hand side. The reverse is true if you use the left arrow. You'll start with the variable on the left-hand side and put the expression whose value you want stored in that variable on the right-hand side. The equal sign works exactly the same as the left arrow. You'll put the variable on the left-hand side and the expression on the right-hand side. It's important that you know that when a statement includes an assignment operator, the result is saved in the variable, but it's not written to the console. So you won't see output in the console, but the value will be stored in the variable. Also, recall that the assignment operators are the last entry on the table of order of operations. So generally, an entire expression is going to be evaluated before R tries to assign that value to a variable. Also, be aware that the assignment operator returns nothing, so double assignment generally doesn't work. And I'll show you an example of where that could come up. So why are you going to use variables? The nice thing is that you can use variables and expressions later, so you can store a value in a variable and then use it in a subsequent expression. All the variables you've defined show up in the environment viewer, which is in the upper right-hand corner of RStudio. Also note that complicated variables, like data tables, can be displayed in the environment viewer by double-clicking on them. So let's look at some examples. I have here in my code window 3 different ways of assigning expressions to variables. So in this first one, I have 4 times 16, and I'm going to assign that to variable 1 using the right arrow. So I run that bit of code. You'll notice that there's no output in the console other than just showing the code that I ran. But now if you look over in the Environment Explorer, you can see that there's now a value, var1, that has been assigned the result of that expression, which was 64. We can do the exact same thing with the left arrow assignment operator. Here I'm going to multiply 9 by 87 and store it in var2. Again, there's no output in the console, but also if you look over in the Environment Explorer, it shows the result as 783. And then lastly, I'll use the equal sign, which again, remembers works exactly like the left arrow. So it's going to take the expression on the right-hand side and put it in the variable on the left-hand side. Again, the nice thing about variables is that you can use them in subsequent expressions. So here I have a statement where I would like to compute the product of var1 and var2. I run that, and if I look in the output window, I'm not assigning that expression to a variable, so it shows up in the console, and you can see that is the result of 64 times 783. You can also assign the result of these expressions to new variables. So if I would like to see what var1 times var2 plus var3 is, but store it in var4, I can do that. And then you can see once again in the Environment Explorer, a new variable has appeared with the value 50,098. If I wanted to look at it in the console, I could just put var4 in an expression by itself, and R will print it out in the console. Lastly, remember that assignment operators return nothing. So if you try and double assign in a crazy statement like I have here, where I'm assigning 6 using the right arrow to X, and then I'm trying to assign 9 to X using the left arrow, R is going to give me an error. So data in R come in 2 forms. There are primitives. These are basic data like numbers or text. They can also be things like vectors or matrices, which are collections of numbers. R also has objects. Objects are complicated data, and they can be almost anything. So things like tables of data, models, graphs, audio clips, these are all stored as objects in R. Importantly though, variables can hold either objects or primitives. While R can store primitives or objects in variables, it shows them separately in the Environment Explorer, so they'll show up in separate tabs of the Environment Explorer. You can save primitives or objects as RDS files. Primitives are probably not so useful, you'll be saving one number, but definitely sometimes you'll want to save objects as RDS files. You're probably not going to make any objects on your own in this class. You're generally going to encounter them as the result of an operation that produces complicated output. For example, you run a model and you'd like to save the results, or you create a graph and you'd like to save it to use later. So from here, you should have a good idea of how to form basic expressions in R.